Hello and welcome. This is T SCAN 20 and today I want to measure a large tool to produce side panels of cars. First of all, I would like to introduce the application itself. What we see is a raw model of a cast blank, and the typical steps in the production is the design of the tool, the production of the tool, and afterwards the calculation of the milling paths. So in today's application we want to do a scan and to find out whether or not there is enough material to compute milling paths. So why do we use T SCAN 20 for the application? T SCAN 20 has got a large measuring volume. It's 4 meters in length and covers the entire tool. Furthermore, it's extremely easy to use. Surface data can be produced within a very short while. And last but not least, the object doesn't need to be prepared, so we do not need target points to measure the entire project. In the next step, I'm going to measure the entire object in GOM Inspect Suite 2020. GOM Inspect Suite 2020 is the standard software for T SCAN. T SCAN has got its own workspace in the software. We can, once the tracking device is positioned, scan right away. Additionally, T SCAN is extremely easy to use and fast to learn. So the next step of this video is the scan of the entire part. And in order to scan, you have to position the scanner above the surface so that the surface is in the measuring volume of the scanner. Pull the trigger, which is here in the handling side of the scanner, and go forward. T SCAN produces large surfaces of the object you want to measure within a very short time. This means the forward speed can be very fast. So what you have to do is to align the scanner, pull the trigger, go forward. That's the scanning speed here. It can be as fast as this. You can measure forward, you can measure backwards, whatever is required to quickly measure the entire part. I have now measured the entire part. Let's see the result in GOM Inspect Suite 2020. I have now completed the scan, and that's what scan data look like. It's a full scan of the entire tool. And purpose of application actually was to find out whether there is enough material to compute the milling path based on a color plot here and specific labels. We see that we have some areas in above the CAD while others are under the CAD. Under the CAD means it is not possible to compute milling paths here as we have a minus. This pretty much means we have to rework the tool to shift the entire surface a bit upwards and remeasure to find out whether after reworking the tool there is enough surface for calculating the milling paths. As the application is now completed, it's time for a quick review. In this application, T SCAN 20 made a great job. Within a very short while, we found out there was not enough material to directly compute the milling paths to continue with the next production steps. Instead, it was necessary to rework the tool to make sure there is enough material to compute the milling path. T SCAN 20 can be used in other applications too, like the inspection of welding frames, single parts which belong to welding frames, as well as mounting parts like tanks or battery covers. Thanks for your attention, take care and see you soon.